All right, good morning, e-learners. When you look at this link, make sure that you see on the email that I sent you that there is the quiz link. Make sure you take the quiz. You have 10 minutes to take the quiz. All right, the other students have already finished their quiz and they're ready to go. Maybe I'm exaggerating slightly. Humorless class, humorless class. All right. Well, the cool thing about today is that it's the same as yesterday. I mean, it's the same class. Like, there's no difference. Why would I teach exactly the same thing twice? Well, it does deal with a different shape or different construction. It's the same darn class. I'm going to give you two postulates. They're the same as the previous ones, except they deal with this one shape. Let's see. Postulate number one was the ruler postulate. I'm going to tell you postulate 3 is the ruler postulate just for a different shape. Like, what is he talking about? And then postulate 2 was the segment addition postulate. Postulate 4 is going to be the segment addition postulate just for this shape that we're about to talk about. Okay? So I would even argue that I could literally say, you know, here's your homework, do it. You should be able to figure it out yourself because it's the same class. But I won't be that mean or that cruel. I will actually teach it to you. So those of you that can see the sheets that I'm handing out can already tell me what the shape is. What's the shape? The shape is an angle. Now, I don't require kids to buy a protractor, although many of you do have a protractor. If you have a protractor, go ahead and get it out. If not, it's not important. If you have one of those horrible metal ones that don't have the dot, you need to use one of my protractors. Protractor, not a. Like, this is a metal one right here. It's got this dot right here. Fisker finally figured out that they need to put a dot on it. If you buy an older one, right? You had one from a couple years ago. They didn't have this dot here. They literally couldn't use it. They sold a protractor that you couldn't use. Does everybody have a dot on it? That has a metal one? Okay, good. It was like I don't know, 10 years in a row that they, I don't know how many years, but it seemed like it was 10. All the parents would buy a protractor. And they would always buy the metal one because the plastic ones always break. And then they would get to class and I was like, you can't use that. It doesn't have a dot. All right. Good? All right. Let's see. Did I not update the calendar? All right, forget the calendar. There's your homework. Now you've had, I don't know, almost a whole week now of seeing what the questions look like. You're kind of getting used to the challenge and the difficulty of geometry, and it won't change the entire year. Yes. My claim is you don't really need this class. You already know what the ruler postulate is. You already know what the segment addition postulate. We're just going to apply that to angles. What? Oh, we got to go over homework, don't we? Mr. C's losing it. Questions on the homework? Thank you, Micah. Questions on the homework? Now, I walked amongst all of you yesterday. We went over many of the problems, so we're going to collect the homework. So let me have your homework. I will grade it. Usually on a quiz day, I want to make sure I have enough time to go over all of the class, so I typically say, I will grade your homework. And you're going to get a chance. Once you're done with that, make sure I get your homework. Homework. I already like this class. Usually, in a lot of classes, we get to the end of the second week, and that's when the kids that never do their homework start to emerge. And I'll just say, you can't pass geometry without doing your homework. This doesn't happen. Okay. We good? Everybody got the homework copied down? We'll take care of you, Danny, don't worry. So we're going to deal with angles. Now, you guys had me for pre-algebra, yes? Do you remember how I defined angles way back 2 years ago, pre-algebra? Anybody? Okay. Angles are made up of two things. Take a guess. Look at it. You can probably figure it out. What are angles made up of?
Two rays.
Two rays. Okay. So here's my magic, right? That is a ray. That is a, notice they both have the same endpoint or the same starting point. So if I squeeze them together to the power of PowerPoint, oh wait, I gotta press the button. There you go. Smart book. It works good on the small kids. All right, we make an angle. So how are we going to find an angle? It's two rays, right? It's a figure formed by two rays that share or with a common endpoint. A figure formed by two rays with a common endpoint. In other words, they both share point B. We good, Danny? We done? Okay. Need it? I should have these grade cards on. We okay? All right. Now, I did teach you this 2 years ago. How do we name angles? How do we name angles? Dots? No. What do you mean?
A, B, C.
So we're going to name it by all 3 points that are there. You agree? What order?
From B, A.
What order he said, let's use the points. And I said, okay, so what order do we write the points?
It has to start at B. But A and C.
That would be one idea. We start at the common endpoint. Turns out that's not the case. Right? We start on not the endpoint. We start on either one of these and stay on a black line. So this is either angle CBA or ABC. In other words, the common endpoint is always the middle letter. Do you remember what we named that thing on an angle? The pointy part?
Oh, the origin?
It'd be a good guess, but no. Right? We call it the vertex. So the vertex will always be the middle letter. We also have a symbol. Chandler, take a guess. What's the symbol? So symbol for segment is a segment. Symbol for a line is a line. Symbol for a ray is a ray. Guess what the symbol for an angle is? Thank you, Chandler. All right. That's the symbol for angle. So this is angle ABC. Notice the letter in the middle is that common endpoint, and I define that as the vertex. We'll write vertex here, another box pretty soon. So in box 1A, we have an angle. We're going to call it ABC. We also could call it, okay, CBA. And now we get complicated. There's 2 other ways of naming an angle. Now you got to really listen to me. You listening? If the angle is floating out there all by its lonesome, it's not made up of other angles. You're like, what do you mean? Well, think about this. If I make an X, how many angles are there? There's 4. So if I'm talking about this angle right here, and this is point B right here, right? I want to talk about this angle right here. And this is point D. Well, it's also the common vertex for this angle, for this angle, for this angle. So only if the angle like this one is kind of floating out there all by itself, guess what we can call it to make our life easier? We can call it angle B. But you can only do that if the angle is by itself. So that's the vertex, but we could call it, because it is floating out there by itself, we call that angle B. And they'll get really stupid, and you will see this a lot in the book. I don't know about today. Today, yes, you will see it today as well, too. When the picture is complicated, and there's lots of angles. I'll go back to my X. How many angles did you say there were here? I would have to put a lot of points to name all those. So what do? They put little tiny red numbers. Look at the book, Mike, and tell me, are they red? Most of the time, it doesn't have to be red, but they will put numbers like 1, 2, I should write in red, 3, 4. You see what I did? That is a shortcut method of writing the angle. It's a label. So we would call the top one angle 1, this bottom one angle 3, the right one angle 2, and that one. So you might have a number that appears right there. Okay? Is that how big the angle is? Is that its degrees? Well, how do you know? Because you will also see that in the book as well, too. How do you know that's not its degree? It's a 1 degree angle. How do you know it's not 1 degree? How do you know that it's not 1 degree and they're telling you the name of that angle is angle 1? Doesn't have the little tiny dot above it. If it has a little tiny dot above it, it would be 1 degree. You will see both of those. Sometimes they will say it's 30 degrees. But if it just says 30, you're not going to see that. It's going to be small numbers, like single-digit numbers. Occasionally, they may get 10 or 11 or 12. But yeah, it's not going to have the dot. So that can also be called angle 1. So there's 3 ways, well, technically 4, but one's just the different order of letters. But there are 3 ways to name any angle. You can name it by points, where the vertex is the middle letter. You can name it just by its vertex, or if it's labeled, you can name it by its label. Who's lost? This is important. Like this is the critical. And since you guys brought it up, I'll just make the statement right now. When you look at any picture in geometry, you can only assume what is labeled. If it's not labeled, you can't assume anything. For instance, and we'll get to this in a second, acute, obtuse, remember that stuff? Is this an acute or obtuse angle? Don't know. You can't assume it. You cannot assume it. In geometry, unless it's labeled, it's just an angle. Yes, it's probably an acute angle, but we're not going to ever assume that. So the picture, a lot of time in most geometry books will say not drawn to scale, right? The same thing with this. If it is labeled, it's gospel, right? But if it's not labeled, you can't make that assumption. Okay, box 2, give me the name of that angle. Go, write it down. Give me the name of this angle right here. Hey, there's 4 boxes. There must be 4 different things you could write down. Nope, we haven't even talked about that yet, defined it specifically. I just want the name of it. There's 4 different ways to name that one angle right there. Acute would be the type of angle. So Wes, what did you name that angle?
DEF.
DEF is one way, right? Jana, what did you name it? FED. Notice both of those, the E is in the middle. Let me catch up with you. All right, but there's 2 other ways. Chris, give me one of those other ways, other than DEF or FED. What's his name? Fred? No. There's 2 other ways. If the angle is floating all by itself, there's no other angles around it, you can call it by its vertex. What's its name? Angle E. And the last one, if it's labeled, everyone, it's angle. Now, you're going to see later on that you are allowed to label if you want to. All right. Done with that. Just write this down quickly, just the definition of vertex so we all agree. 1B, vertex. It's the point of intersection of the 2 sides. The 2 sides are made up of rays. The vertex is B right here, where the 2 rays come together. Those are the sides of the angle. Side, well, I don't know if it's 1 or 2, but here's one side, there's the other side. Where they come together, where they intersect, that's called the vertex. By the way, this is nothing new. This is literally the same slides. I just changed the word course 2 to geometry and just used the same darn slides. This is not the new stuff. But I do need to remind you this. The plural vertex is vertices. Vertices. We talk about triangle, we'll talk about the vertices of a triangle. That's the pointy parts of the triangle. Talk about a pyramid, the pointy parts of a pyramid. Those are also called vertices. We okay? All right, moving on. Oh, there's the vertex right there in blue. Guess what we do with the vertex of any angle? That is how we That is how we measure angles. We measure angles by using their vertex. You can be honest, and we won't make too much fun of you. You can be honest, we will not make fun of you. How many people do not know how to use a protractor? So let me teach you. Micah, you sat in class 2 years ago. We did the same class.
I don't.
Okay, so let's go over it. So look at your protractor in front of you. Here's mine. I got this big yellow one. So somewhere on there, you got a dot. Yes, everyone? My dot is right here. You have a dot on yours? A hole? Yeah, okay. So that's this part right here. Guess where you put the hole?
On the vertex.
I put the hole on the vertex. The more accurate you are, the more precise you are, the closer you will get to the real number. Okay? Now, here's the thing that will kick everyone's butt. How many scales are on your protractor? How many scales are on your protractor?
3. Wait, no,
I got to look at yours.
no,
There's 2. Notice there's 2 sets of numbers. There's an outer one and kind of like an inner one. You see them? Both scales start at what number? Both scales start at what number?
10.
They do not start at 10.
They don't start at 0.
They start at 0. The inner one starts at 0 on the right, and the outer one starts at 0 on the left. Now, yours may not be labeled, but it's still 0. Do you everybody see where 0 is? Okay. What does the scale go up to? 180 degrees. Okay. So, how do you actually use this thing? Well, one thing is you need to look at the angle. Here's my method. I call this the Mr. C method. Hey, is this a big angle or is this a small angle? So if you measure this and you get 150 degrees, you're reading the wrong scale. Can everybody look at that and say that's a small angle as compared to a big angle? What would a big angle look like? It would look obtuse, which we haven't defined, but it would look like that. There's a big angle, right? The ones that were close to 90 degrees are the ones that kick your butt because you're like, well, I'm not sure. Is it 89 or 91 degrees? And you can read the wrong scale then. Okay? But most people can kind of eyeball whether it's big or small. Okay, so how do you measure it? Watch me. For those of you that said I don't need to do it, you find your hole. You put the hole on the vertex. Okay, it's on the vertex. You got to do one extra thing. You got to line up your 0 with the bottom ray. Line it up really good so that the hole, you can kind of see the shadow. I mean, Seth can. You can kind of see the shadow goes right through 0, and my vertex is right on that dot. Now, you said this is what, a big or a small angle? If you screw this up and you read the wrong scale, it says it's 155 degrees. You see that? It ain't 155 degrees. You're reading the wrong scale. Now, if you're measuring an obtuse angle, yeah, it could be 155 degrees. So just make sure you look at the angle first and say big angle, small angle. Oh, it's a small angle. Oh, it must be the other scale. Now, the second way you can screw this up is make sure you look at the 2 numbers that are left and right. This says it's between 30 and 20. Sometimes you'll just count wrong. You'll say, oh, 30 plus 5 is 35. It's not. It's not. It's between 20 and 30. So that's not a 35. That's actually, well, mine's a little bit less. Mine looks to be about 34 degrees. So I would call mine.
34. It's 24.
I would call mine, and I just did it wrong. Thank you. Mine is 24 degrees, plus 1 for Matt. That was good. Plus 1 Matt. There's my first mistake in geometry. Plus 1 Matt. No, that means he gets 1 point on his quiz or test of his choice. All right, if I make a mistake, which I clearly just did. All right. Hey, what kind of angle?
Large.
It's big angle. Now we got a problem with this one. Watch me. I put the vertex on that. I line up my 0. I don't know where that is. So guess what you have to do? You're going to take, before you measure it, you're going to take your straight edge. You're going to put it up to the line that you can't measure on. And you're going to carefully, if you do this, you know, because if you're off a little bit, it's going to really throw it off. But you're going to really try to line it up really accurately. And you're going to, see what I did? Extend the line. Does that make sense? Now, when I put the hole on the vertex, I line up the 0. I said it was what, a big or a small angle? You screw this up, you say, oh, it's 35 degrees, because that's what it says, 36. You're using the wrong scale. I know it's a big angle, so it must be the other scale. It says it's between 140 and 150, and it's a little bit less than 145, so it's 144. That's how you measure when you have to extend the line. I purposely gave you some on your paper. You'll have to extend the line in order to measure it. I will not test you on this. Okay, you have 4 angles. Guess what I want you to do? Measure them, use your protractor. If you need help, don't be embarrassed.
My protractor doesn't have numbers.
You need a new protractor.
Yes, I do.
His protractor does not have numbers, literally. Good luck with using that one. All right, here you go.
So what is the second scale for? I've never
Well,
used it.
you use both scales. If you're measuring, it depends upon the orientation of the angle.
Oh,
If I flip the angle around this way, you're going to be using the other scale. Right. Yeah. All right, let's do one again. So put the dot on the vertex. Okay, so here's the issue is that you see this line that says 180? You got to line that up with this line. So I want you to also extend that line. Because you can't see it, right? That might still be too short. So you can see if it works though. Line it up. And then on this side, oh, that's perfect. See how it lines up perfect? Now, was this a big angle or a small angle? Okay, so if you rate it wrong, you're going to say, what, 128? You're reading the wrong scale. So it'll be the inside scale. How big is it? Looks like about 53. So write 53, and that's how it's done. Oh, yeah, perfect. Perfect. For the ones that have the clear one, a lot of times you don't have to extend the line. Anybody struggling? So I would extend this line as well too. So see this now? Let's extend that line. Because you can't read it. Keep going, keep going, keep going, keep going, stop. Now, put, let's extend this line. Now, put the hole in the vertex. And then see where the 180, see you're a little bit off? Yeah, now read it. What does it say? 50. Yeah, I think about 53. That's what it looks like. You guys, feels good? Good? You're getting 58? This one? This one? You said this one? Well, this one. Okay, so big angle, small angle. So it's between, so it's between 130 and 140. It looks to be about 30. Good? We're measuring these ones. So here's what you do. See how short these are? Let's make them longer. So extend that line. All the way across, all the way across, all the way across, all the way across. Now let's extend. You just gotta keep going, you're getting longer. Okay, I'm gonna put the hole on the vertex. See the hole in here? I'll put it on that vertex. You do because you want to line it up. So it's a little fiddly. Okay. Now you want to make sure that that side, that's why we extend it. So that's perfect. So it's what, between 50 and 60. So that's about 50. I agree. And the rest just like that. You got this? Oh yeah, you're doing it. Wait, I would extend this one too. I would extend on all of those. I would extend both of them. Okay. And you're going to see that probably still working on that. Put the hole on there. Put the hole on the vertex. And you're going to see the problem. You don't know if it's going to go here, right? So we can line it up with the 0, so we could just extend that in the other direction as well. Keep going further than that. See how big your now you got this. All right. Now put that hole on the vertex and you'll see why we do this. You see over here, you line it up with the 0 really well. And that, now we can, oh, this is a big angle or small angle. And so notice if you were at this scale, you can do 40, 50. You bring it to this scale. So it's between 130 and 140 about. I think it's a little bit less, but sure. All right, if you're good, you can get this within, I don't know, let's say 2 degrees. All right, if you got to be neat though. All right, who's got the first one? How big? What'd you guys get?
53.
Now, I'm not saying I have the definite answer, but I'm saying I got 53 as well, too. You got like 51, 52, 53, 54, 55, good to go. You got 43 or 126, you got problems. All right, how about this one? How big?
30 to 46.
So 30 and 46 are really far off.
28.
28, 29, 30, those are kind of close. I got 30, right?
I said 30, and you said that was far
Oh,
off.
wait, I was thinking of the wrong. I was thinking
I'm just saying between your two numbers, you guys were 5 off, right?
I thought you said far off.
All right, how about the top one?
That's-
How much?
I got
133 was pretty popular. I'm not saying mine's right. I got 134 when I measured it. And the last one, obviously, is
91.
some people will argue it's 89 or 91. I mean, I tried to make it 90 degrees, right? All right. I don't think you will ever be asked to use a protractor again unless you are in the trades of some sort. You're building stuff. But there you go. There's your last shot at using a protractor, maybe in your life. Okay? I don't need them right now, but make sure I get my protractors back. All right, we're going to do this really quick. We're going to get really stupid.
Yay.
You do need to eventually write this down. Okay, remember with a segment, we had a name of a segment and we had the measurement of a segment, and they looked differently. The name of a segment had the line over the top. What did the measurement of the segment have? We said it's 2 inches long. How did we write that? Without the little line. We do the same thing with angles. Watch me. It's different though, but it's the same idea. What's the name of this angle? With the little angle symbol, right? So that's its name. If we want to measure it, I said we're getting stupid here, right? If we want to measure it, we don't write it angle B equals. Don't ask me why, we just don't. So this is, if you want to say how big it is, this is what you write.
Oh my
An
God.
italicized M, we leave the angle symbol, we still have a B there. If you see this, it's asking you what?
Measurement.
The measurement of angle B. So the M is read as the measurement of angle B. Why do we do that? Why couldn't we just put an equal sign? We would have been okay. I'd been okay. But no, geometry does this. So wrap your head around that. Tonight for homework, you see this, they're saying, hey, that's the name of it. If you see this, they're asking you, and typically it'll be an equal sign, they're asking you how big is the angle. And no, tonight you will not, never in the book will you ever use your protractor, ever. If they are asking you how big the angle is, it's some calculation that you'll be doing. You're never going to pull out your protractor again. All right. So this should be a quick review. Oh, by the way, do you guys need to write that down or can you remember that? We'll see. All right. You guys should already know this. How do we classify angles? And we've already talked about it, kind of, sort of. The smallest angle is called a. If you need to write this down, write this down. Right? You will be tested on this, but many of you already know this. An acute angle is an angle that's between what two numbers?
90 and 90.
0 to 90. Any angle that's between 0 and 90. See what that says?
Oh,
It says the measure of angle C is bigger than 0, but less than 90. Make sense? If you already know this, you certainly don't need to write this down. But if you don't know this, this is testable right here. What's the next one? The next biggest angle? A right angle. We classify a right angle as having how many degrees? Exactly 90 degrees. If it's a right angle, almost universally we put a little box at its vertex. The box indicates right angle. Okay? If you see a box, they're not going to tell you it's 90 degrees. They're showing you it's 90 degrees. Okay? So measure of angle C is exactly 90. It's the only one it's exactly. The rest are, ranges. Oh, there's one more. I'm sorry. I lied. Next biggest one, obtuse. How many degrees is an obtuse angle? Not 90, not 180, but somewhere in between. Bigger than 90, less than 180. The measure of angle C is bigger than 90, less than 180. And the last one, the one everyone forgets that I forgot as well too, Straight angle. How many degrees in a straight angle? We will use this frequently. That a straight line has how many degrees? Okay? A straight one has 100. In other words, if I measure from here to here, it's 180 degrees. Hey, guess what number's on your protractor? 180. That is the measurement of a straight line or segment or ray. 180 degrees. If you go from one point to the next, you've gone 180 degrees. Is that brand new for anybody? Okay. Moving on then. Around the room, we'll start with Chris. What is it? Right? Danny? Oh, I was looking at Matt, but yes. And that one, if it is 90, that is.
It's not 90, it's either 80, it's either here or
According to
two.
Matt, it's not
It
90,
doesn't
but
have
for
a
the rest of
square.
us with 90, that's a. It's a right angle. Okay.
It
So
doesn't have a
cute.
square, it's not 90.
Agreed. Now, you are not required to put a square, but earthquake. If there is a square, they're telling you it's 90. But we measured it, and we found out it was 90. Okay. How did I start the class? I said I'm going to give you two postulates. They're exactly the same as yesterday. They just deal with angles instead of segments. So, recall, a postulate, you don't have to write this down, is something that we accept to be true because it's obvious, right? We also call it an axiom. Theorems are things that we will prove that true. We're not going to do a theorem yet. And then lastly, corollaries come from theorems. I give you a theorem, the Pythagorean theorem, and then I get something from that that just falls out really easily from that theorem. All right, so this is postulate 3. This goes in your book of truth. In your notebook, not on the sheet of paper. In your notebook. I need you to write, at a minimum, that right there, and you need to understand it. This is called the protractor postulate. You're like, well, he drew a line there. There's no protractor. Oh, we'll get to that in a second. Postulate 3 is called the protractor postulate. It is exactly the same as the ruler postulate, except it applies to angles. Well, there's no angle here yet. I need to draw some angles. Okay. Now, I'm going to show you the words. They are in your book on the bottom of, right here. Oh, my word, are there a lot of words in red? I'm going to show them to you, explain them to you. I would suggest that you do not write them down. But you have to understand what I'm saying. So here's what I'm saying. Let's go back to the ruler postulate. The ruler postulate says that you can take any line, put 2 points on it, set 1 as 0, set 1 as 1, and you can get a number line, right? We can do the same thing with a protractor. I make one line, and I make at least 2 rays. At least 2 rays. The first one is 0 degrees, and the second one is, think about the ruler postulate. The first one is 0, and the second one is 1. I have now made the scale, right? I've now made the scale, make 179 more of them, and you got from 0 to 180 degrees, okay? This is the same idea. There's one angle, right? You're like, wait, there's 2 here. Okay, there's one ray. Let me catch up. And we're going to say that the angle between here to here is 130 degrees. You're with me? Okay. Now I'm going to draw another ray that goes from here to here. Okay. And I'm going to say that the measurement of AOC is 50 degrees. So let's label here real quick. You don't have to do this on your paper. So from here to here was how many degrees? It says 130. So that's 130 degrees. You're not going to see that. And then I said from here to here, it's 50 degrees. So how big is this angle? How do you know that? Now, from here to here is 130. From here to here is 50. How big is this angle? How did you do that? How did we do the ruler postulate? The distance between any 2 points is the difference, and then take the absolute value. It's subtraction. This is exactly the same as the segment. or sorry, the ruler postulate. It's just done with a protractor instead. If you want to find the measurement of any angle, you simply take the larger angle and subtract the smaller angle, and you get what's left over. Does that make sense? Right? Could you do it with addition? Sure. What added to 50 is 130, right? That's where we get subtraction and addition with, or the concept of subtraction and addition. Now, that's the idea. Now, you've got to be brave and say, I got that. If literally all you heard was blah, 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 you've got to stop me because we're going to use this all the time. Okay? I guess you got something. Okay. Believe it or not, that's postulate 3. Write this down. We got 2 minutes left. The last postulate is called this. It's the pair to the segment addition postulate. This is called the angle addition postulate. All right, I'm not going to wow you with this, but it says this. If you want to know how big the big one is, what do you do with the 2 small ones? You with me? If you want to know how large the big one is, add the 2 small ones, and you got the big one. That's all it says. I've left off all the words to make your life easy. You want to see the words? Watch that. There are the words.
No. Get away. God.
All of this explains, if you want to know how big COD is, you subtract the 2. That's what that says with all those words. Okay, that's why I left off the words. And postulate 4 isn't too bad. It just simply says you want to know the big one, add up the 2 small ones. Yes. Okay, hold 1 second. Let me get my protractors back. Clean up around your desk. Mine or yours? My protractors. My protractors. My protractors. My protractors. Thank you, thank you, thank you. All right, question.
Go ahead.
Okay, where? Well, just remember, it's going to be the same thing as the, so it's saying AL bisects KT. What do you know about bisects? It cuts things in. Yeah, that means that angle 1 and angle 2 are the same or different. They are the same. So 1 equals 2. So which number am I doing? 30. That means 1 equals 2. Set these 2 equal to solve the equation. Right? 1 is 7x plus 3. 2 is 6x plus 7. If they're, yeah, we're going to solve for x. We're solving for x. We're not finding the angle. We're just solving for x. We could find the information. So, if I have an angle and I cut it in half, angle 1 and angle 2. What do you know about angle 1 and angle 2? So if I told you angle 1 is 30 degrees, how big is angle 2? Now the only thing is I don't say it's 30, I say it's, I don't know, I'm making this up, 2x plus 7. And the other one is 4x minus 1. They're still equal, so simply, now give me the real things. One of them is, what is it?
6x plus 7.
And the other one is?
7x plus 3.
Solve. They're both equal, right? Has 2 minutes passed? Go.
Okay. Once you have your homework, you're done. That means I can do anything massive. As long as you have your homework, you're better.
All right, e-learners, make sure that you check the link that I gave you today. We'll also have a link to the quiz that you need to test. You have 10 minutes to take that quiz. Good luck. If you have any questions, send me an email.